Hello everyone. So today I would like to introduce the algorithm for children. So I learned this algorithm when I tried to finish the problem in LeetCode, which is 1192 critical connection in the network. So in fact, this is a very classical problem in graph theory. And to find the critical connection, we can use Trojan or algorithm to find out all of the critical connection in the network. So first, we need to know what is critical connection first. Okay. Okay. So we will take this graph for example, which is let me draw about it. 1, 2, 0, 3. Okay. So critical connection means that if you remove the edge and it will affect the node to be visited. So for example, if I try to remove the edge between 0 and 1, okay, so will it affect any nodes to be visited? No, because we still can visit it all nodes with 0, 2, 1, 3 in this way. However, if we try to, let me change to another color. If we try to remove the edge between 1 and 3, we will find that uh, we remove the only path to the node of 3. So this is a critical connection and it will affect that we cannot visit the node 3 anymore. So in this problem, we need to uh, output the edge of 1, 3 in our result. Okay, so now we know what is critical connection. So next step, how do we use Trajan algorithm to find out the critical connection in a network? And how this algorithm work? Okay, so first we need to know how children find out the critical connection. In fact, critical connection is the edge which is not part of the cycle in the network. So take this graph for example. Here is a cycle between 0, 1. Oh, wait a second. Let me draw it again. 0, 1, 2, 3, right? So there is a cycle between node 0, 1, 2. And critical connection is the edge which is not part of the cycle in the network. So that means the edge between 2 and 3 is the critical connection. Okay, so in fact, after you looking about several graphs, you can find that this uh, this answer makes so much sense. So if I draw another mm, networks here, maybe 4, 5, and here's a cycle. So the only way can in the only critical connection is 2 and 3 because even though you remove another connection such like this one, it still can visit like this way 3, 4, and 4, 5. still can visit all nodes. So what do we want to find? So children told us what we want to find for us critical connection is the edge which is not belong to any circle. Okay, so now we know the algorithm how to find the critical connection. So then next challenge is how to find the edge which doesn't belong to any circle. So the work of children is that let me show again. I will show the same graph in the problem. Mhm. Which is 0, 2, 1, 3. Okay. So how children algorithm work? So he will record a array of the depth, and the array of the depth, uh, for example, four here is four nodes, right? So for depth 0, it means that when we try to DFS traversal from node 0, and in this whole process of traversal, the minimum depth the minimum depth he will get in the whole process. This is very important. It will record the minimum depth in the process. Uh, for example, this depth is 0, and he will visit the node which is the next node is node 2, and so the depth would be 1. And next it will visit node 1, so the depth will be 2. Okay, so next step he can visit two node, right? One is node 0 again, and another one is node 3. So if he I will change to another color. If he try to visit the node 3, he will get depth 3. Okay. And if he try to revisit the node 0, original depth would be depth 3, right? However, we want to return the minimum depth he has visited in the whole process. And now he visited the depth of 0, which means that the minimum depth he has visited is 0. Okay, so now he will become to return depth of 0. Return back depth of 0. Okay, so it means that okay, he now the node 1 finds that, oh, I find a depth which is smaller than myself, and that also means that I have visited before. I have visited the node before, and so he knows that this might be a node belongs to my circle. So this must not be our critical connection. So here he will not add the edge between 0 and 1 into the result. He will again return 0 back to the node 2. And again, 0 is smaller than the current depth, which is 1. So he know that, okay, so node this node must also be in the part of the circle. So he will not add the edge between 1 and 2 into the result, and again return 0. Okay, so here that the return value is equal to 0. So he know that this is also part of the circle. So any edge, the three edges between these three nodes, any one of them is not belong to our result. Any one of them is then the critical connection. So let us see about another case, which if we visit node 3 after visiting node 1 at this way. Let me change to another color, is this one, right? The purple one. Okay, so back to the current depth, which is 2, and next depth is 3. So we will return the, now we already know that our depth will return the minimum depth which visited in the whole process, right? However, when he come here and find there is no any other child node, so the minimum depth the nodes visited in the whole process is still 3 for the node of 3. So for the node of 3, it is still 3, and he can only return 3 to the parent node. So here return 3. And for now let us back to the node 1. So node 1, he find that, oh my god, the return depth is equal to the current depth plus 1. So it means that mm, the edge between node 1 and node 3 not belongs to any circle. Because if there is a circle, then the return value should be smaller than the current depth, right? However, now the return value is bigger than the depth. And specifically, uh, equal to the current depth plus 1. It means that the edge is the critical connection we want to find. Okay, so let me finish the whole loop. Now return 3, and okay, so now he know this is the critical connection, so we can add it to the result, which is 1, 3. Okay, so here again, the node 1 will return the minimum depth he visited currently, right? Okay, so the minimum depth he visited currently is his own depth and the depth of the child node. And the depth of the child node is 3, and his own depth is 2. And the minimum one is 2, so he will return a value of 2 back to the parent of which is node 2. Here he will return 2. Okay, so next let's come to the node 2 and again compare between the depth of his own node and the depth of the node 2 and the depth of the child node, which is node 1. The depth of the child node is 2, and the depth of the node 2 is 1. So the minimum one is 1. Okay, so here node 2 will return 1 back to the node 0. Okay, so now let's see. The node of the depth of the node. Let us compare the depth of the node 0 and the depth of the child node, which is node 2. The depth of the child node 2 is 1, and so the minimum one is between 0 and 1, which we will return 0. Okay, so this is the whole two cases we need to discuss in this problem. One is if the return depth is bigger than the current depth and also equal to the current depth plus 1. It means that this is the critical connection in the network. And if the return depth is smaller than the current depth, it or equal to the current depth, it means that it might belong to a circle. So that don't need to add into our result. Okay, so now we have the whole structure and the idea of the problem. So now we can come to write down our program. Here I will use the program language of C++. Okay, so to list out all the possibility cases of the critical connection, so we need to make DFS traverse from a random one node. Okay, so here, okay, so okay, our condition is if remove Wilson, so it doesn't have any requirement for us our result. Okay, so first we will need a structure map. Okay, and vector first, which is result, and that is also what we want to return in our result. And just like I said, we need a array of depth. First I will build up a map for our connection. So it would be so if there are n servers, then the nodes will come from 0 to n minus 1. So it would be okay vector n vector nt. Okay, so start to traverse connections and then add into our map. So first start 0, push back I. And also this is undirected graph, so we also need to add in another direction, push back I0. Okay. So next we also need just like I said in before, we need a graph. We need a array which recorded the minimum depth the node has visited in the whole process. So vector, which is that's okay, and I would call it maybe n minus 1. Okay. So now we start DFS from one of the connection. And random connection I would like to choose for the node 0. Okay. Now we will revert. Okay. So each level of the traverse we need to return in this picture we can say we need to return a minimum depth of the node, right? So the return value will be integer. So here the return value is integer traverse. Okay. So we need current node, previous node. I will show you if we have record a previous node, it would be very convenient for us to add the edge into the result if we find the critical connection. And this is current depth, and now we need depth. So next is our connection. At the end is our result. Okay, great. Okay. So first, we will pass the value into it. So it would be current value. We will start from node 0. And we would like to add a dummy node, which is -1 at the node -1. So we need to also be careful that when we try to add the critical connection into our result, the current node cannot be 0. Okay. And the current depth is 0. And that's a result. Okay. Next. So first, our depth would be okay. So and so let us our depth array in the level of the depth array will start from 1. That is what I assume. And that will also be convenient for us to make sure whether our depth has been updated. So current depth plus 1. Okay. Now we will try to visit any child node. So void auto child and we must don't want to visit it previous path, go back to the same path. So we will make sure whether the child node is equal to the parent node. If it is equal, then we will continue. So now let us handle with two cases. If the child node is still not be visited, then you have to say that we initialize the depth array with -1. So if the depth array is still -1, it means that it still not be visited. So if depth child is still -1, it means that child still not be visited. And if not, it means that child already be visited. So here, if child is still not be visited, we will start to traverse, make a DFS traverse over it. So we also, okay. So for example, so we come from 0 and 2 and 1 and 3. So in the whole process, we want to make sure whether the node 0 can get more the minimum depth. So here, depth curve will try to make sure whether he can get a smaller depth by traverse through the nodes. So current, he will start from child node, and the previous ones will be our curve, and current depth will be okay. Yes, depth +1. So now here you need to be careful. You cannot write with depth curve the value in the depth curve. It means that you will add 1 for the twice time. Okay, so you can just use curve depth. This is a little tricky part. And then the depth result. Okay. Now, and if child node already be visited, so and count 0 to 1, and next he want to come back to 0, and he finds 0 has been visited. So depth curve depth can be depth curve and depth child. Okay, so now we come back to the perspective from 0, node 0. When we finish the DFS traverse, you will get the minimum uh minimum depth. So if he get if he finish the whole traverse in this circle, I think he will get the depth which is equal to his current depth. And in this way, any edge in this circle will not be added into the result. But in another cases, if we come from 0 to 1 and to 3, okay, and to 3, and here at this level of the first search traverse, he will return 3 back to the node 1, and here the current depth is 2. So here we will try to add it into our critical connection. So the return value is depth logger, and it is equal to current depth plus 1. And another thing I have told it before, the -1 is just our dummy node. So our current node cannot be 0. So current cannot be 0. And we can add the age into our result. Result which and brief. And here we need to give a return value, right? The return value is the minimum depth the node has been visited. So it would be our array value. Let me check there. Is there anything we lost? Mm, okay, let me try the result. Okay, it seems great. Let me submit it. Okay, so I got accepted on this solution. So this is all what I want to share about the solution for this problem. So in this way, I think this problem is very good practice to make sure how you understand the Trajan algorithm. To find out the age which doesn't belong to any circle, that is the critical connection in a network, and use I think the most important part in this algorithm is that you use this array to record the minimum depth the node has visited in the depth first search traversal. Okay, so you need to make sure you understand the definition of this depth array. Okay, this is my video about the Trajan algorithm. Thanks for listening, and you can comment if you find anything maybe incorrect or any question can leave in the comment.